Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the May-June 2022 Pure Mathematics P3 paper from Cambridge 9709, and this is the variant 1, paper 3-1. And this question is about complex numbers, and one of my students has asked me to answer 7 part C. Of course, as usual, I will go through the whole thing for those of you who might need that. So question 7 part A. So it says a complex number u is defined by u equals root 2 minus a times root 2i over 1 plus 2i, where a is a positive integer. It says express u in terms of a in the form x plus iy, where x and y are real and exact. So basically what we have to do is we have to rewrite this in such a way that we have basically made the denominator into a real number. It's very similar to rationalizing denominators when we're doing things in terms of surds. In this case, we have to make the denominator a real number. So we have to, it's called realize the denominator. So basically, we're going to multiply both the numerator and denominator by the conjugate of 1 plus 2i. The thing that when you multiply 1 plus 2i will cause the I term to be cancelled out. And what we're going to do here is we're going to think about, what happens when you have a difference of squares. Okay, the middle term disappears. That's what we're going to do to this. We're going to rewrite this. We're going to say, okay, this is 1 plus 2i. So we start off with what they gave us. But we're going to multiply it by its conjugate, which is 1 minus 2i. So when you expand this, you're going to have 1 times 1 and 1 times minus 2i and 2i times 1, which gives you minus 2i plus 2i. They cancel out. Then you have 2i times minus 2i, which is going to give you negative 4i squared. And as we know that as I is defined as the square root of negative 1, therefore I squared is equal to negative 1. So the I squared will be replaced by minus 1 and there will be no I term left. But whatever we do to the denominator, we must do exactly the same thing to the numerator. So I must also multiply that by 1 minus 2i. Okay, and that will give us our answer. So let's just simplify this now. Root 2 times 1 is root 2. And root 2 times minus 2i is minus 2 root 2i. And minus a root 2i times 1 is, as it is, minus a root 2i. And then we're going to have a minus a root 2i times minus 2i. Well, minus and minus gives you plus. You're going to have a times 2, which is 2a, times root 2 times I squared. Okay, so you have positive 2a root 2 I squared, and all over, and as we said, we're going to have the middle term disappearing here, so you'll have 1 and minus, and 2i times 2i is 4i squared. Okay, so we'll end up with the 4i squared there, which is the whole purpose of this was to make the denominator into a real number. So this is going to become a real number because, as we know, I squared equals negative 1. So let's simplify this. Okay, so if we take this part here, I'm going to write these two together. This is a number term, and this will be a number term because I squared is minus 1. So I'll have root 2. I'll have plus 2a times root 2 times minus 1. This I've written over there. And here I've got minus. If I look here and see what's common, I'm going to have minus. I'll write the minus sign. I'm going to have root 2 times I, root 2 times I, times, I'm going to have 2 minus a. In fact, it has to be plus ay because minus times plus is minus. So it will be minus root 2, minus 2 root 2i, and it will be minus a root 2i. Okay, good. That seems to be fine there. So I've written those two together. What was this here? That was a minus 1. Okay, let me just, should be a bit neater here. That was a negative 1 here. Okay. So this gives me root 2 minus 2a root 2 minus root 2 I times 2 plus a. And I can even write this a bit simpler. I can take out root 2 as common from these two. Root 2, 1 minus 2a minus root 2i, 2 plus a. And what have I forgotten? I've forgotten the denominators. Okay, so I've just dealt with the numerators. I should have done them at the same time actually, but I kind of forgot. Let me just do that down here. Okay, so this should be over, of course, 1 minus 4 times minus 1, which is going to be 1 plus 4, which is 5. So I can write these as separate denominators over 5. Okay, so now I've basically got what I wanted to. I've got them as two separate terms, and I have, x plus iy. So let me just write this in exactly the form they wanted. So root 2, 1 minus 2a over 5. That's like the first term without the I, minus I times root 2 times 2 plus a all over 5. Okay, so this is the answer to part A. Okay, so we've written it in this form, x plus iy. In terms of A, and we got x and y are real and exact. Okay, exact, root 2, in terms of root 2, and real. Okay, and those parts are. So there's the answer to part A of this question. Now we're going to move on to part B. And now for part B of this question, we're told that it is given now, or is now given that a equals 3. So now when a equals 3, we can say u is going to be equal to root 2 times 1 minus 2 times 3 over 5 minus, we'll have I times root 2, 2 plus 3 over 5. Okay, so this gives us u equals root 2 times, that's 1 minus 6, which is minus 5 over 5, minus I times root 2 times 5 over 5. So we can see here the 5s will cancel out. So we're left with u equals negative root 2. And here the 5s will cancel out. We're left with minus I times root 2. So now, this is what u is equal to when a equals 3. We have to rewrite this in the form here, in this exponential type of form. Okay. So when we have r e to the power of I theta, what we should understand is r is equal to the modulus of the complex number, and theta is equal to the argument of the complex number. Okay, so we have to find the modulus and the argument of this, and then we can write it in this form. Simple as that. Okay, so now, how do we find the modulus and argument? Well, drawing a little Argand diagram always does help. So I'm going to draw a little Argand diagram over here, and we have our point. We have the imaginary part of our complex number, and we have the real part of the complex number. Always the real is horizontal and the imaginary is vertical. So you have negative 2 on the real part, negative root 2 on the real part, and also negative root 2 on the imaginary part. So our complex number, if we illustrate it, will be somewhere down here. Okay, and you can see here that we have to express it in terms of r and theta. So first of all, this length is root 2, this length is also root 2. So we can say that r is equal to the square root of root 2 squared plus root 2 squared, which is square root of 4, which is 2. So r is equal to 2. Okay, so we got r equals 2. That's one thing. Now we want to find theta. Now theta, if we go this way, it's going to be more than 180. And they've told us that theta should be between minus pi and pi, which is, within, basically, either stop there, and then if you can't go any further than that, you have to go this way. So it's going to be this angle over here. That's our theta. Okay, that's the argument of u. Now, what is this angle over here? If we find this angle, we can find that angle. Now, here we have the opposite and the adjacent side being the same. So we can say the tan of this angle is 1. So inverse tan of 1 will be pi over 4. You can put that in your calculator, but you should understand tan of 1 is pi over 4. Okay, so that means our theta, therefore, is pi minus pi over 4, which is equal to 3 pi over 4. So we can say that our complex number u is equal to r, which is 2 times e to the power of, that's going to be 3/4, it's going to be negative 3/4 pi. It's negative 3/4 pi. Why negative? Because we're going in the negative direction. So whatever this should have been, basically, it should be negative that. Okay, negative 3/4 pi. So let me just write that again. So I can say our complex number u is equal to 2 times, and we're going to have, that's our r, e to the power of negative 3 over 4 pi I. There's the answer to part B. We've rewritten this complex number in exponential form. And then part C says, using your answer to part B, find the 2 square roots of u. So let's say, for example, that the square root of u is equal to w. Okay, is equal to w. That means that w squared is equal to u. So that means w squared is equal to 2e to the power of minus 3/4 I. Okay, so if the root of w is equal to if the root of u is equal to w, then w squared is equal to u. So w squared is equal to this. So to find w, you can just take the square root, positive and negative square root of both sides. You have root 2 e to the power of minus 3/4 I. Now, so that's going to give you plus or minus root 2 times e to the power of, now what's the square root of e to the power of minus 3/4 I? My handwriting is a bit messy there. E to the power of negative 3/4 I. Remember, we're going to take a half of this power. It's like the square root is like raising to the power of a half. So we can take a half of this power, and that will be the same thing as finding the square root. So we can do it like that if you want to. You have e to the power of negative 3 pi over 4 I, and we want to find the square root of that. Okay, that gives us plus or minus root 2 times e to the power. Now, when you raise something to the power of a half, when you find the square root of something, it's like raising it to the power of a half. So a half of minus 3/4 pi, minus 3/4 pi is minus 3/8 pi. That's the power of minus 3 over 8 pi I. Okay, so we can say that w is positive root 2 e to the power of minus 3 pi over 8 I, or it's equal to minus root 2 e to the power of minus 3 pi over 8 I. Okay, now this, we have to readjust this because we know r must be greater than 0, as they told us. Okay, this r is greater than 0. Here, this is r is less than 0. Okay, so we got to think about how we can deal with this. So this w, one of the answers is given by this, and the other answer is given by that. Now, you can think of these as being like opposites of each other in a way. So if I take the answer that we're given first, it's going to be, the argument is going to be minus 3 pi over 8 I, and the radius is going to be root 2. So minus 3/4 of 8 pi is going to be in this direction over here. Okay, it's going to be somewhere like this. It's going to be somewhere in this direction. It's going to be less than half a pi. It's going to be somewhere like this. Okay, that's going to give us, let's say that's z. Oh, that's one of the values of w. That's w, and this point here is, basically this angle here is minus 3 pi over 8. Okay, so that's the argument there. And root 2 is the length. Now, negative w is basically, it's like the opposite in terms of like, it's going to be going in the opposite direction. The negative of a complex number is like in vectors, it's like parallel, but in the opposite direction. So negative w will be over, or negative root 2 e to the power of minus 3 over 8. They're exactly the same thing, but it's going to be in this direction over here. Okay, so this is the negative value of this. This is negative root 2 e to the power of minus 3 pi over 8i. So how do I express this in the right form? Well, if I take this as, so this is, if I take this as basically, this angle is the same as the angle over there, which is, this would be 3 pi over 8. Now this angle over there is going to be basically pi minus that. So it's going to be pi minus 3 pi over 8. So that's going to be 5 pi over 8. Okay, so I can rewrite this instead of having a negative. Okay, instead of having a negative in square root, so I'll have root 2 e to the power of 5 pi over 8. That will give me the answer with a positive number instead of a negative number, and it will take us exactly where we want to go. Okay, so this is going to be, this angle here is 5 pi over 8. Okay, so those are our two answers. W is equal to root 2 e to the power of negative 3 pi over 8, or root 2 times, can't have negative, or root 2 times e to the power of 5 pi over 8. So those are our two solutions. Oops. Get rid of that one. Okay. Right, so those are the two solutions here to get those two answers. I hope that was clear. That's the question that the student was asking. I hope that was quite clear. And well, thank you for watching. Now, other questions from this particular paper I will put in the playlist that will appear at the top right of the screen at the end of the video over here, and other questions from the topic of complex numbers I'm going to put in the playlist over here. You can subscribe to my channel by clicking on this link, and the video linked at the top will show you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.